All right, so we're going to talk about experiments. Hopefully, before all of these videos, you've read the textbook, but it's particularly important, I think, before we talk about experimental research and correlational research, that you've read the textbook material. If you haven't, I actually would suggest that maybe you pause here and go back and do that, or at the very least, make sure that you go back and do that after you've listened to the lecture, and then maybe come back to the lecture and listen to it again after having read. But experimental research, the thing that, one of the most important takeaways from this course is for you to understand that true experiments, because we talk about experiments in a generic way often, right? And we use it as sometimes even a substitute for the word research or study. But an experiment is a very specific kind of thing. When we do experimental research, we can draw conclusions about causation. We can draw conclusions about how one variable affects or causes change in another variable. And it is the only research design that allows us to do that. We can't do that in case studies. And as we'll talk about in detail, we cannot do that with correlation. And so only with true experiments can we do that. And there's some really central reasons for that. In a most general way, we can do that because the researcher has control over everything. And so we can essentially isolate what is leading to the outcome that we see. Because we're controlling everything. And as you hopefully know from the reading, right, in experiments, we have two different kinds of variables. We have independent and dependent variables. And we have two different kinds of groups. We have experimental and control groups. And it's the nature of those variables and the groups and how subjects get into the groups and what happens to them when they're in groups that defines experimental research. And that's going to be really important. Ideally, all of our research would be experiments, but as we're going to talk about, it can be really hard to accomplish this, and so we often settle for something else. So let's talk about the variables. There are two kinds of variables, as we just said, independent and dependent variables. The independent variable is an environmental condition that is changed or manipulated by the researcher. So it's the thing that the researcher is curious about how it affects people. And so it is the cause in our cause and effect story here. The dependent variable is the effect in our cause and effect story, and it's a behavior or a condition that changes or that you think might change because of what you've done with the independent variable, right? So one way of remembering that is that the dependent variable depends on the changes to the independent variable. And sometimes it's hard for students to understand or to look at a research question and figure out what's independent and what's dependent. And I think the easiest way to do that is anytime you see a research question, I would like you to put it into this form, like what is the effect of blank on blank, where your first blank is always going to be your independent variable and your second blank is always going to be your dependent variable. So the first example you can think about, it goes back to what an example we were talking about earlier, which is what is the effect of studying on college grades? And in this case, right, because we put that in this way, what is the effect of blank on blank, or the effect of studying in college grades, you can easily know that the first blank has to be the independent variable, and the second blank has to be the dependent variable. So if you think about a different research question, right, I'm doing a study to see if people who do yoga have lower levels of stress, you can look at that and say, okay, what is the effect of, right? What is the effect of, and then think about that for a moment, and you could pause and think about it if you want. But essentially, right, what is the effect of yoga on stress levels, right, or something like that? And then that first blank, yoga, has to be the independent variable, and the second blank, stress, has to be the dependent variable. Okay, you guys will have some practice with this in your small groups. But that is kind of your first step with that. And then the other thing, right, we have two groups. We have an experimental and a control group. The experimental group is the group that gets the independent variable. So if we were really interested in what is the effect of yoga on stress, then our independent variable, the yoga, is the thing that would happen to our experimental group. So our experimental group would, have some exposure to yoga, and whatever we decide that's going to be. Our control group does not get the independent variable. They are our comparison group, right? Their whole purpose is to give us a baseline or a comparison so we can see what would have happened if we didn't give them yoga. And so the control group does not get the yoga. They often will get something as a substitute. So maybe they get time in a quiet room so that something happens to them. And that's to keep things as consistent as possible, right? So if we just give yoga and then nothing to the control group, then maybe it's not the yoga itself. Maybe it's being in a group. Maybe it's being in a peaceful room. We want to make sure we replicate things as closely as possible while not giving the exact same thing or the thing that is central to our question. It's really important that everything else be the same between the groups. So it's really important that the people at the beginning that you make sure that before they get yoga, that your experimental group and your control group are really exactly the same. Not every individual in the groups needs to be the same, but as a group, their characteristics need to be the same. So you couldn't compare, for example, a group of men and a group of women, and then give the men yoga and the women not, because then you couldn't be sure. Is it the men, is it the gender, or is it the yoga that's making a difference in stress levels? The example I like to think about with this is I bake awesome chocolate chip cookies, but maybe they could be better. If I brought you all a sample of my attempt for better cookies, and I said, give a taste. I've changed these cookies. Or, do you think the change is good? Part of it, you would say, like, essentially, I need a control group. I need the original ones to compare, right? So that makes sense to you, I'm sure. If I changed both the chocolate chips and the brown sugar at the same time and then asked you whether they were better, you might say, yes, these new ones are better, if I gave you a comparison, the original recipe also. But then you wouldn't know whether it was the brown sugar or the chocolate chips because I changed two things. And so that's why everything else has to be the same. The experience of the yoga will be different, but everything else between the groups has to be the same. And if you accomplish those things, then you can draw conclusions about it saying that the yoga caused the stress levels to be different because everything else was the same. It couldn't have been anything else, right? So again, you're going to have opportunity to talk about this with your small groups and of course to ask questions if you like in the live discussion. But those are the really important points about that. One of the basic things that has to be true for experiments, and it ties to what we were just saying, is that the subjects can't come to you pre-grouped. So you can't, if you look at people who are already doing yoga versus people who don't do yoga, right? You're not putting them into the yoga, no yoga groups. You're not putting them into the experimental control group. They come to you as people who do yoga and people who don't. And they say, oh, look, the people who do yoga have lower stress levels. It's tempting then to say yoga causes lower stress, but the people already doing yoga may very well be different in other ways as well. Because you haven't started with two identical groups and then changed something. Like there's a whole list of other ways that they're different, right? Maybe people who do yoga have more money and they can afford to do yoga and therefore they have less stress. Maybe people who do yoga have more free time and that's why they're less stressed, right? All these other things that might be different. And so if you're going to do an experiment, you need to assign people to groups. You cannot start with pre-existing groups. And then you need to control everything else that happens to those groups to make sure only one thing is different. So we just talked about what the experimental group and what the control group is. So some of this we've talked about already. All right, so we said this already too. And you can look at these. There'll be slides up for you to take a look at. So if I'm going fast, you can go back and look at those slides. This is a not great picture, but it was a quick way to get it up here. But this is a good way to visualize experiments. And I'm going to suggest that whenever you're trying to figure out an experiment, you kind of draw it out for yourself like this. So that you start with a population, you derive your sample in all the ways we talked about to get a representative sample from your population, and then that sample gets divided by the researcher, randomly assigned to two groups, where half the group becomes the experimental group, half becomes the control group. The random assignment ensures that at this point, these are identical groups, right? You start with them being identical. If you don't start with them being identical to each other, then it's meaningless to talk at the end about whether they're different. They started different. So they have to start off identical to each other. And then your experimental group gets the independent variable, and your control group does not get the independent variable, but everything else stays as close as possible to the experience of the experimental group, so that only the independent variable is different. And in the end, you measure the dependent variable for both groups and compare to see if the groups are different, right? So this is, I think, a really good way to draw things out. And so if you can remember how to, kind of this as an example, I think most of you could construct an experiment for just about anything. Um, so, the story I always tell is when I was in junior high, I had to do a science experiment, a science project for class, and I decided that I was going to do a project with goldfish. There was a period of time when I would like do these science projects with small pets of some kind, so that my parents had to get me the pet. And so one year I did hamsters with something, and this year I did goldfish. I think it was seventh grade. And my hypothesis was that if I fed goldfish earthworms, they would grow bigger than goldfish who were fed fish flakes. And so I started with 4 goldfish, two in one bowl, two in the other. I got a bunch of earthworms, fed them to the goldfish. I had no idea who I was then. I fed them to the goldfish in one bowl, and I got fish flakes and fed the other two fish, goldfish flakes. And in the end, the ones who got fed earthworms did grow bigger, but there was a fatal flaw to my design. I did not use bowls of the same size. Happened to be in a larger bowl. And if you know anything about goldfish, that would always mean they were going to grow bigger. They grow to the size of their container. But even if that weren't true, the fact that they were in a bigger bowl and I was also feeding them goldfish, two things were different, right? It's like my chocolate chip cookie recipe where I changed the brown sugar and the chocolate chips. It doesn't work anymore. I can't draw conclusions about causation anymore. Um, so I'm going to pause there because actually we'll talk about this here. One other thing we do sometimes in experiments in order to make the groups identical is that we use blind or double blind studies. And the idea here is that we have some deception involved in order to keep the conditions identical. So if I was doing an experiment looking at whether or not a new medication helped with depression, if I told you you were getting the medication, that knowledge may actually have what we call a placebo effect. And a placebo effect is kind of a mind over matter thing where if you believe you're getting medication, you might report that you're feeling better. And so blind study is when we don't tell people what condition they're in. So we don't tell them which group they're in. Or sometimes we just don't tell them about the purpose of the research because if we do, that might affect their behavior. And there's all kinds of ethical rules about when we're allowed to do this and when we're not. There are double-blind studies where the research assistants who are actually interacting with the research subjects also don't know, so that they don't know who's getting the real medication or not, so that they can't, by accident, affect how the experiment is going. And so both of these are an effort to control as many variables as possible, and this is just an added attempt at that. So here we're going to pause, and in the last video we'll talk about correlational research.